Hello guys, in this first video of this course, we will see what GitOps is, GitOps principles and workflow, and how does GitOps enhance DevOps, and finally we will talk about GitOps use cases. So this video is designed for individuals who possess prior knowledge in DevOps, have a solid understanding of containers and Kubernetes, and basic understanding of virtual control systems such as Git is important. So let's get started with this question. What is GitOps? Well, GitOps is just a set of best practices for managing infrastructure and application configurations. It relies on Git. This means that the entire code delivery process is controlled via Git, not only the application code that is controlled via Git, but also like the infrastructure and the applications configuration is also or also managed via or controlled via Git. So we write and manage our desired configuration in scripts and store all in Git repositories. Then GitOps controllers automate the updates and rollbacks. So GitOps in simple terms is just an approach that uses Git to manage and automate the deployment of applications and infrastructures and always ensures that the desired state, what we defined in our Git repositories, matches what is in our target environment. So let's look at some GitOps principles and workflow. GitOps uses declarative configuration files to define the desired state of infrastructure and applications. And these files are all stored in a Git repository and serve as a single source of truth. Nobody has direct access to the environment where the application is running. As an example, the Kubernetes cluster to perform this manual update. And Git is the authoritative source for all changes and updates. So this makes much easier to perform rollbacks, troubleshooting of failed deployments, and auditing for compliance and security. There is another point which is automatic deployment. When a pull or merge request is made, all changes are stored in our Git repository. So they are all verified and approved by the team. Then these changes are automatically pulled via some GitOps agent. We will see some of these GitOps agents later on in this course. Then are applied in our environment where the application is running. As an example, the Kubernetes cluster. Also, we have another point which is continual reconciliation. So these agents, GitOps agents, constantly monitor the current states, the actual states, system states that is running in our environment, for example, the Kubernetes cluster, and also monitor what is happening in our Git repository, like the desired state, and always try to keep this, like the actual state, the current state in our environment looks like the desired state that is defined or stored in Git repository. So let's see an example of deployment without GitOps. First, the developer commit and push changes to the application repository. So this will trigger some pipelines to build the app, to do some integration tests, build a Docker image, then push this image to the Docker hub, our registry. And finally, we apply these changes manually to the target environment, in this case, the Kubernetes cluster. So we use kubectl. With GitOps, we delay actually this step. So we don't apply these changes manually to the cluster. Instead, we update our infrastructure repository. So we update the manifest files or the Helm chart that is stored in our infrastructure repository. Then we open a pull or merge request to verify the changes. If everything is fine, we notify the agent, and then this agent will pull these changes, approve it changes, and apply them in the Kubernetes cluster. And same time keep synchronizing it with the repo. So this is how it works with GitOps. So what changes can be found in this pull or merge request? Well, changes can be related to the application configuration or changes related to the Docker image for example, updating the tag or the version, or for example, related to some fixing some errors or bugs, or changes related to the Kubernetes cluster configuration, or can be like a new declarative configuration. New, for example, you are creating a new object or a new resource in your cluster, or finally can be changes related to the environment itself. How does GitOps enhance DevOps? By introducing this declarative configuration approach to manage the infrastructure and application deployments, teams can express their desired state in a clear and concise manner. And by leveraging Git, we will enhance collaboration, and teams can work together and contribute changes through pull and merge requests. So all changes are auditable, and all rollbacks can be easily executed by just reverting to a specific version in Git. There is another point related to automation and tracking the environment changes. So this is done via like the GitOps tools. So we can continuously monitor the Git repository for changes. And when a change is detected, the tools automatically pull the updated configurations and apply them to the target environment. So let's see now some of the GitOps use cases. You can use GitOps practices with your own applications that are developed and maintained by your team, or you can use GitOps practices for other third-party apps that are used for monitoring the environment, such as Prometheus, or for example, for managing your secrets using Vault. Also, GitOps practices can be used to manage your own infrastructure, such as the Kubernetes cluster configuration, and so on. So what's next? I think that's enough theory up to this point. So in the upcoming video, we will provide a brief overview of GitOps tools. We will introduce Argo CD, one of the most popular GitOps tools. We will learn how to install it, utilize to deploy applications in a Kubernetes cluster. So that's all what I really wanted to cover in this video. Hopefully you guys have a better understanding of GitOps and all its benefits within DevOps. So if you enjoyed, please like it and see you in the next video.